Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. In this video, we'll solve this problem using the concepts of average rate of change and instantaneous rate of change. As per the problem, an object drops from a cliff that is 150 meters high. The distance d in meters that the object has dropped at t seconds is modeled by d at t equals 4.9 t squared. In part A, we have to find the average rate of change of distance with respect to time from 2 seconds to 5 seconds. Let's start with part A. Average rate of change represents the slope of secant line that joins 2 points on a function. This is a very important concept we need to understand and memorize. In this case, we have to find the average rate of change from 2 seconds to 5 seconds. We can use the slope formula to calculate the average rate of change using the given function d at t. The formula for average rate of change, or AROC, is d at 5 minus d at 2 over 5 minus 2. Next, we should find the values of d at 5 and d at 2 using the given function d. For d at 5, we should sub in t as 5 in the given function. I get 122.5 and the unit is meters. This is the distance at 5 seconds. Next, we can find d at 2. We should sub in t as 2 in the given d function. I get 19.6 and the unit is meters. Now we can use these values to find the average rate of change. I get 34.3 and the unit is meters per second because the unit of distance is meters and the unit of time is seconds. This should be the final answer for part A. Now we can answer part B. Find the instantaneous rate of change of distance with respect to time at 4 seconds. Instantaneous rate of change represents the slope of tangent line at a given point on the function. In this case, we have to find the instantaneous rate of change for the given distance function at 4 seconds. Since instantaneous rate of change is the slope of tangent line to the function, we should find the derivative of the given function d at t because the derivative of the function represents the slope of tangent line to the function. This is a very important concept we need to understand and memorize. So the instantaneous rate of change, or IROC, is equal to slope of the tangent line, which is equal to the derivative of the d function. Now we can calculate the derivative. In the given d function, 4.9 represents the coefficient of the term. It's a constant, so it should stay as it is. We can find the derivative of t squared with respect to t using power rule. As per power rule, we should move the exponent 2 to the front and subtract 1 from 2 in the exponent. So prime of d at t is equal to 4.9 times 2, which is equal to 9.8 times t. The exponent of t is 1. We don't write 1 as an exponent, so it's just t. So prime of d at t is equal to 9.8 t. We have to find the instantaneous rate of change at 4 seconds. So for IROC, we have to sub in t as 4 in the derivative of the d function. I get 39.2 and the unit is meters per second. This is the instantaneous rate of change at 4 seconds. Now we can answer part C. Find the rate at which the object hits the ground. In part C, we have to find the instantaneous rate of change for the d function at the time when the object hits the ground. We are not given the time at which this object hits the ground, so the first step is to find that time. We are given the distance function for the object. The object is dropped from a height of 150 meters. So we have to find the time it will take the object to travel a distance of 150 meters, because when the object hits the ground, it would have traveled a distance of 150 meters from its dropping point. So we should sub in d at t as 150 and solve for t. We should divide both sides by 4.9. 150 divided by 4.9 is equal to 30.6, rounded to one decimal place. Next, we should apply square root to both sides. Square root of 30.6 is equal to 5.53. I get t equals 5.53 and the unit is seconds. So it takes the object 5.53 seconds to reach the ground. Now we can find the rate at which the object hits the ground by subbing in t as 5.53 in the derivative of the d function. So we get 9.8 times 5.53, because the derivative of the d function is equal to 9.8 times t. I get 54.2 rounded to one decimal place and the unit is meters per second. This should be the rate at which the object hits the ground. This should be the final answer for part C. So these are the steps you have to keep in mind to solve a problem like this one. I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.